All right, we're all being recorded now, so no smack talking. All right, so here we go. All right, so tonight what we're going to be talking about, we're going to be talking a little bit something called the Common Delivery Framework. This is a set of automation libraries that's built on top of a product called CodeFactory that we'll be spending some time using today, talking about. We're going to be talking about a bit about application layer design and why we chose what we have for this, why we do this, and what's the purpose of it. How does CodeFactory work? We'll get into some demos. And the demo code I'm about to show you today, I'm actually using live with customers building real software here in Phoenix. The reasons to leverage the automation, and then we can answer a lot of questions. The Q&A slide I put in this deck at the bottom because it's always what everybody else does, but please don't hesitate to just ask questions as we go. Okay. The goal is, so what we're talking about with the Common Delivery Framework is it really is designed to solve three distinct problems that those people that design and build software deal with. One of the things we focus on is standardizing how exceptions are handled. This, for most development teams, is probably one of the most overlooked pieces of the design of a system. So what we focused on with the Common Delivery Framework is being able to group exceptions into something that has been managed, and then stuff that we're being captured for the first time. Being able to have standardized categories. One of the biggest problems with exceptions is there's literally thousands of different types of exceptions you can have, whether you're using Java or .NET or C++ or stuff like that. It's how do we take and manage that into something that's meaningful to developers, and then we take advantage and use it. And then finally, how do we guarantee that we return safe exceptions? One of the biggest ways software is hacked today is through exceptions getting bubbled up to the screen where we can actually see stack data. And sometimes there's sensitive data in those stack traces that can lead to different security violations, regulatory problems, things like that. How do we make that safer? That's one of the goals from an exception handling perspective. Second is logging. Probably the second most thing people do not do in application code is how do we get logging as a first-class partner back in our app code? For a lot of developers, logging is considered as a luxury, when really, if you want to be able to troubleshoot and maintain systems, it's really critical to have good logging in your code. So one of the things CDF does is we do standardize on the Microsoft extension logging that's provided by Microsoft. We've extended the capabilities of logging with just some simple helper methods that make it a lot easier to do a lot of common things, hence the Common Delivery Framework. And today, for the first time, we're about to release a set of automation for people that author their own applications. And this is what we call an automation for a maintenance-centric architecture. And we'll talk about what the goals of a maintenance-centric architecture are and how they work here as I go through the code tonight. Okay, so what we're going to talk about tonight is building applications that use application layer-based designs, meaning that we have multiple projects in Visual Studio that output multiple DLLs, and we break the system into what we call the running joke. We used to call it the 7-layer burrito. For those of you that remember 7-layer burritos from Taco Bell, you'll get the joke. But we now call it the N-layer burrito because we size the application to X number of layers, or in this case, N number of layers, based on the complexity and the needs of a particular application. So the goal is, when designing and building the system, we build it into multiple application layers. Each layer fulfills a target purpose. This is important because this is where most application functionality falls down, is we mix functionality inside the same layer, and we end up with really poorly maintainable code that leads to lots of rewrites. And then the third thing, when we talk about the layer burrito, is layers are connected to each other through two methodologies, either through service contracts. And what we're talking about is a service contract. I make a web API call using REST, or I use SOAP with something like WCF, or I use gRPC, or remoting. For my really old timers in the room, that's what we call service contracts. The other way is we interconnect these layers together using interfaces. And those interfaces that we talk through conform to the .NET standard implementation. And during our conversation tonight, the .NET standard implementation will hopefully make a little bit more sense of why we recommend that and how that helps us with technology change over time. For the application demo that I'm going to be showing tonight, we have a standardized model of layers that is implemented to make this automation run clean and smooth. And they are covered in these layers that we've identified. The first one that we have is we have a library that stores application models. And these are just plain old CLR objects, basically app class. They're just basically C# classes that contain properties. And they store the definition of what the application data is. And we use these app models throughout the entire application, all the way sending data all the way back to the database, all the way to UI, whether that's run mobile device, and a browser, and a client app, whatever, doesn't matter. And this falls, and we generally require .NET standard for this. So it's compatible with multiple different platforms. Next, we have the abstraction layer. The abstraction layer is per request from servers and transforming it back to and from app models. So this is what is used generally by your application, whether it is a mobile app, a Blazor application, or a JavaScript app, or anything else. They subscribe to these abstractions, and the abstractions does all the heavy lifting of getting data to and from the service tier. Next, we have our service technologies. The service technology implements a specific service. So whether this is SOAP, REST, gRPC, or whatever. And then we have a model layer just for that. You shouldn't say server, it should say service model. And this contains the same data classes that are for a particular technology. So we have these for gRPC, we have these for REST, and so on and so forth. Next, we have a logic layer. The logic layer is just that. This is where we run our business logic. Now, different architectures have different needs. You may have more than one logic layer. In this case, this is where we're going to host our core app processing from our services back. So if you want to call it service logic, great. Logic, whatever you want to call it. This is where we run the actual business-centric application data that we run to run our application. Once again, this logic we actually run in .NET Standard. And there's a couple of reasons why that we'll get into from a maintenance perspective as we go. Next, we have our data contract. For those people that are new to app development, one of the things we generally recommend is when accessing data technologies, whether they're databases or external services you don't even manage, we recommend something called a repository pattern. And this data contract layer holds the definitions for those repositories. The reason why we store it externally in this own layer is so that we can change our data access technology over time. For example, a lot of my customers are making decisions. Do they even want to stay with things like SQL Server anymore? Maybe they want to move to MySQL or the flavor of the month open source database engine, or they're moving to NoSQL technologies. So by having these data contracts, the rest of my application will be able to continue to operate as I change out these technologies without impacting the implementation of the application. Next, we have our data implementation layer, and this is done by specific technology. So this is where we take those repository contracts and we implement them for a target technology. Tonight, we're going to be using SQL Server as our technology demonstrator. And then finally, we have the data model. And the data model is, once again, plain old CLR objects, just classes with properties that are used with a target technology. These are generally using attributes and data from a particular ORM mapper or data access technology and how we map and pull things together. So these are the common layers that we use when building up an application. And then based upon the target user interface type or other services or things like that, we then add additional layers for those. Now, the reason behind having all these layers is twofold. Number one, it reduces the footprint of each chunk of application code. By doing this, Each one of these serve a single responsibility. So my extractions, all they do is make calls and hand data back and forth. My services, all they do is transform from a service technology back to the app models and hand it off to the logic layer, and so on and so forth. In our demo application, we'll actually review and go through this and show how this works. Same thing with the data access and so on. Okay, why are we wasting our time doing this, what we're about to demo tonight? For those of us that have been writing code for a long time, there's a lot of boring code we're stuck writing. And the definition of boring code is anything that's highly repetitive and it's the same flipping thing 9,000 times for a given application. So our goal is we're going to stop writing repetitive code as much as possible. By doing this, we're going to reduce bugs. Most of our bugs come from copy pasting of repetitive code because we get bored or we take shortcuts, things of that nature. The other reason we want to do as much automation as possible is we want logging to become a critical implementation in our code again. So that when I actually run my code, I have logging everywhere. And I don't have to sit there and manually type in the logging code because that takes a long time to do. And not every one of my customers can buy frameworks that do it underneath the hood. And a lot of times that impacts performance. The other reason why we want to do automate boring code is we want to standardize the approach on how we handle exceptions. Not only to get a better handle on how exceptions are being managed, but also to make it easy to understand for developers who come onto my teams and work with me will know how to deal with these issues. The second major reason why we're doing this, we're trying to level the playing field. For a lot of developers, the architecture and the platforms that we're building are getting more complicated, not less. So this reduces the bar of entry for development staff. It allows development staff to come up to speed faster and get an understanding of usage without having to literally fuddle their way through trying to figure this stuff out on their own. That's one of the core goals. And the other one is we're focusing on design and implementation of functionality now, not just code. Let me explain what I mean by that. So our goal is to what we like to call move to a hotspot-based coding approach. So what I mean by that is in tonight's demo, I actually only write code in 2 physical spots and that's it. All the other layers are auto-generated. It'll make sense when I show you what I'm talking about. When we write, anytime we get into handwritten logic, the goal is to have 2 initiatives that drive it. The first one is it requires creativity, requires us to engage our brain and solve a problem. That's one of our design goals. Number 2, it requires design and innovation by the staff. Those are the things we need to be focusing on now. The days of handwriting everything are gone. And the companies that are handwriting everything will get phased out over time. It's just a fact of life. We need automation. There's not enough developers to go around. People are desperate. We got to get better at what we do. That's kind of the focus of why we're doing these things. Okay, so what is CodeFactory and how does it work? So for my developers, we integrate, Lifecycle Delivery created a platform component that directly plugs into Visual Studio. It doesn't plug into Visual Studio Code. It does not plug into Visual Studio for Mac. We are working on versions of it that will do that at a later time, but now we're focusing on standardizing our platform on Visual Studio at the moment. Visual Studio, the CodeFactory product that we're working with runs just like C# or Razor. It is a literal extension of Visual Studio. So it's not really a plugin. This actually runs as part of Visual Studio. This is an interactive tool for developers that allows for automated code generations or software factories to be used for updating application code. And what it allows you as a developer to build your own automation. You don't have to learn how the compiler works. You don't have to know the back end of the SDK for Visual Studio. We take care of all that for you. And what this boils down into is these core areas, the C# model builder. So what this does, this will build a real-time data model on the fly of all C# code. And it allows you to have real-time access to the code implemented in projects. And you can use that data coming out of that source code to generate your own code. So an example tonight is, I'm going to show you how we're going to start from a simple little entity framework object, and we're going to ingest an entire service layer all the way to the abstraction layer in a few small steps. And that's just some of the things that we use it for. We also have direct project integration. So what that means is you have full access to the project system. You can add, remove files, you can create folders, you can basically do any interactive management of the project system inside of Visual Studio you want. You also have direct access to the editors inside of Visual Studio. So as we do real-time code changes, and we want to write those out to the editor, it'll real-time update the editor windows on the fly. So you'll know everything that's happening as the items occur. We also have dialogue integration. So with the type of code we work, you use WPF to create your own custom UI screens that you can display in Visual Studio, just like a normal dialogue inside of Visual Studio. So if you need to get information or gather information from your developer, if you want to display information to your developer about something the automation did, you have full access to it. One of the demos we'll be working on later this year is I can literally show a graphical stack of code and literally drag and drop components. It'll auto wire up interfaces and everything on the fly just from dragging and dropping code around. And finally, source generation. One of the big things that we're focusing on is how do we transform data from data models coming out of C# into other languages. So we take C# code, we can emit TypeScript code or SQL code or whatever really you want. There's really no limit here. And these are just some of the things that we have working right now. We actually have another project where we're literally real-time transforming web forms applications into Blazor applications because we integrated the HTML toolkit directly into CodeFactory. So there's really no limit on what you can do. The limitation is really what you decide you want to limit yourself to. So with that in mind, what we're going to be doing is we're going to be taking this stuff from the Common Delivery Framework and we're going to run a little demo. Any questions before I dive into Visual Studio here? Okay. So a couple of basic things. This is going to be the most underwhelming and potentially impressive demo you've ever seen all at the same time. So what we've got here is I've got this huge demo database with 2 tables in it. It's huge. I got a user table and a departments table. My user table has a primary key, bunch of fields, and an identity column that I use to link to my departments table. If a DBA was present, they'd already be laughing at me for my pitiful data model design here. But I'm building it this way on purpose to prove a point. So one of the things that we're doing tonight is we're taking advantage of Entity Framework and Dapper. We're actually using both together in this project. So what I want to be able to do is I want to be able to build up a very easy to use set of services so I can manage my table data. And we're going to be reusing these components all over the place. So tonight, we're going to go ahead and automate out how to manage our database code into a series of web services. And we'll talk about how to wire this stuff up, how to put it together, and all the parts and pieces. So the first thing I did in my project is I ran the db scaffold context command. And what this does from Entity Framework is it allows me to connect to a SQL server. I can take a database connection and say, hey, I want you to take all the tables and all the other objects. I want you to project them into an application library. And I want you, when you project it, I also want you to create entity objects for me and give them what they call data annotations or attributes that tell me a little bit more about that database table. I did that earlier. And what that came up with is what I'm about to show you now. And that will be stored in our model for SQL Server repository. So this is going to be our model objects. And if you noticed, it created a user table and it gave me a bunch of attributes. Tell me about it. The ID is the key. There's I got some constraints on some of my fields. Notice my middle name and my age are both nullable. And then I've got this foreign key link to department ID with an inverse property back to users. And then in my department table, there we go, same thing. So this is just standard out of the box vanilla functionality. It's been around forever from Microsoft. This is the latest version. This demo is .NET 6, by the way. Everything we're doing tonight is .NET 6. So what I want to be able to do is I want to build a series of management objects so I can start managing my data and taking advantage of it and using it in my application. So to do that, I've created a app model, and this is going to store all of our objects that are used application-wide. So I'm definitely going to want to have my user and my department moved into the app model, but I don't want to have those nullable types in there. Not a good thing. So there's some business logic requirements. Don't want to do it. I want to build some app logic. So I got a logic layer. I want to build some interfaces so that when I build my repositories, they have a common interface. That way, if I change my mind and move it to something in the cloud or a different database platform, the rest of my application isn't impacted by it. So we're gonna make sure we have that contract. Then for tonight, I want to implement my data repositories as a SQL object. So in this case, we're going to do demo.data.sql. This will be our SQL repository that we're going to implement. Once I get that stuff done, I want to be able to implement a web API version of this, and I want to be able to implement a gRPC version of this. And I want to make sure that when we do this, it's fairly quick and easy. So one of the things you're going to notice in here is I'm going to crack open and show you the root of the solution here. And you'll notice at the root of the solution, there's this file called common delivery framework.net automation delivery.cfx. That stands for CodeFactory extension. And all you have to do is drop it in the root of your solution, right next to your solution file. This auto creates this folder. And if you open it up, you notice there's a little GUID in here. And you'll notice there's a bunch of DLLs in here. These are all my automation library DLLs that I just put together for this demo. So now we can do some automation work. Okay, so the first thing I want to do is I really want to create some repositories, build my entity objects, and do all that stuff. So Bruce, if I'm going to custom build a repository for a table, what do you think? 2 or 3 hours for all the parts and pieces?
In my particular case, no, but then again, I've written a tool to do that. For the average developer, yeah, that's a day's worth of work.
Okay, so let's build one. So we're going to go, so I'm going to do is I'm just going to go straight to the entity. I'm going to right click on it. And you notice down here, we have this update SQL model and create SQL repository. So we're just going to click on create SQL repository. So when we do that, what this did is it did a couple of different things. And by the way, it's done. The first thing it did is it went ahead and created my model object for, so here is the actual app entity now. And I went ahead and told it, hey, go ahead and pull over those length constraints to make sure that I take advantage of those in my app code. So if I'm working in Xamarin or Blazor, WPF, WinForms, web forms, oh God, I hope nobody does web forms anymore. Whatever, it's still fully compatible. So you can get to that data. The next thing I needed to do is I actually updated entity framework. And the way I did that was I extended the user object in a separate file called a transform file. So one of the biggest hits to most application code is they have these utility libraries you can download and use that allow you to transform your code from one format to another. But a lot of that's done heavily through reflections. And you pay a pretty steep performance hit doing that. So instead of doing that, we actually build this stuff on the fly. So I can keep updating that user table and keep updating it, and the transform will keep updating over time. So in this case, you'll notice that I have a static method off my user now to create the SQL model. So it'll take an app model, it'll automatically create me a new user object that's used by NDB framework, it'll populate all the data. If I'm creating the app model, it'll check all of my nullable types, and for the nullable types that are value types, it'll automatically do my get value and do a straight conversion. And this is built into our actual logic, which we will be going through the logic tonight. And everyone can download a copy of it if you'd like to. It's out on GitHub already. So you guys can play and do whatever you want with it. So now that we've got that part built up, next thing we need is a repository. So we're gonna go into our SQL, we're gonna go look at that user repository that was just created. So first, here's abstract. So this is the standard, and notice there's nothing entity framework centric in here. It's literally just give me my app model. I need to be able to insert, update, and delete. Now, the insert, update, and delete is built automatically. We automatically build the basic CRUD operations out of the box. You can then do as many additional commands as you want. This is just the stuff that we do automatically. Once we do that, if we go look at the repository itself, one of the things you'll notice is the repository inherits the interface. It then has a built-in DB connection string object, and this is part of Common Delivery Framework. It's just a little data class that allows you to inject a connection string. And we're also injecting the logger. I'll show you how we're doing injection in just a minute. And then you'll notice that we have the insert, we have the update, and we have the delete user logic already built. What's important is we're also doing bounds checking. So the bounds checking piece of this logic is focused on making sure that we pass non-nullable, we make sure that we're passing data we expect into the system. So this is built into the framework. We have, in our logic, we automatically determine if I don't have a equals something after the parameter, I know that we should bounds check it if it's a nullable type. We also do bounds checking for string types automatically. So if it isn't, it'll throw a validation exception up to the next level, make you go take care of it, the standard things. In this particular design, we are using everything's atomic, one in, one out. So we create our own context on the fly. We do our operations. We return the results. We throw the context away. We catch managed exceptions, and I'll explain the concept of managed exceptions in a little bit later into this. This also has something to do with Common Delivery Framework. And then if we get any DB update errors, we check if there's a specific SQL exception. If that's the case, we go look for it. If not, we then generate a managed exception by the type of SQL error that we have. So when we look at this, so we'll go ahead and peek that definition. All this is doing is looking for specific well-known error levels underneath the hood. And of course, it's not going to see this because that's in the other library. But what it does, there's certain level managed error levels. It'll tell you if it was a timeout, if it was a permission problem. It'll map to the correct managed exception type and return that type. We'll talk about that in a little bit. And then and these are always identical. We always have, and we always log enter, and we log every exit. So here's our, we're at an information level, we're coming into this method. We're coming out of this method, and we're grabbing some of our logger stuff. Now you'll notice this is wrong. Oh, nope, this one's right. I got my bug in the other one. I have a bug intentionally thrown in this code so we can go fix it later. But no, everything here shows exit data. So the reason why we do this is when we're troubleshooting things, it makes it very easy to determine in which particular library we're having a problem and where the problem originated. And we just cycle through each one of these. So if we do the same thing, if we go back and we do department, we right click on department and create the repository. As you can see in just a few seconds, Here's our department with just an ID and a name. It's real difficult. Once again, it gives you the exact same code, this time for the specific department. Okay, so when we were helping our customers go through this, one of the things that we determined is that there's a clean separation between our data access layer and the logic itself that we maintain. So when we did our automation, we put a natural breakpoint at the logic layer. And I'll show you how we take advantage of that here in just a minute. Is there any questions so far I can answer for anybody? Since I can't see the screen, guys, you'll just have to pop your mic on and ask your questions. Okay, we'll keep rolling. All right, so now that we have built out our data repositories for our two tables, now what I want to be able to do is I want to be able to implement some logic. So my logic is the first time I'm going to write the actual code, but I'm not going to write much. So the first thing we're going to do is in my logic class, I'm really just going to clone my repository for now. I'm just going to make a copy of my user repository. I'm just going to paste it in my logic, and we're just going to make a few modifications to it. So I'm going to rename this. I'm going to call this iUser management. Yep. I'm going to change my namespace over to logic. Just like so. There we go. And then just clean up my documentation. There we go. We'll just get rid of the into storage part of this. There we go. Okay, so we're going to start. This will be our first generation of this. So now I'm going to save this, yay team. And now what I want to do is I want to have an actual logic class itself. So I'm going to go ahead and just add a new class. And yes, I'm even using Ring Sharper along with everything else here. And we're just going to go ahead and call this once again, user management. Okay. There's my user management class. I'm going to go ahead and I'm going to inherit that user management. One of the things I'm not going to do though is I'm not going to use the built-in capabilities of either ReSharper or Visual Studio to implement my interface. There's a reason for that. I'm lazy. Let's talk about what being lazy means. So I'm going to right-click on user management. I'm going to say, hey, let's go ahead and add those missing members from that interface to the class. So what you're going to notice here is it automatically built all my bounds checking on the fly for me. It built my try catch blocks. It did all my exception management for me on the fly. So now all I have to really focus on, and it updated my documentation for me. All I have to really do now for this logic class is build a constructor, and then implement my logic, which will only take just a quick couple of minutes. Let's do that real quick. So I'm going to create a private read-only, and we're going to create this as a user repository. And we're just going to call it repository. Keep it simple. And that's what's going to store the user repository that this logic class is going to talk to when updating the database. So all I have to do now is build my public user management. And we're going to do ilogger, pass in the name. Call this logger, yay. User repository. And we'll call that repository once again. There we go. So now, one of the things you may notice here, and this is new to Visual Studio 22. Notice how it automatically wrote the next line of code for me. This is using the AI automation for Microsoft, and I'm a big believer in. Look how lazy it's turning me into, which is fantastic. So now there's my constructor. So now all I really want to do is this particular logic is going to be fairly straightforward and simple, not much to it. So all I'm going to do is just create my user result. I'm going to go ahead and call my repository to make the database call to add a user. So I'm going to go result is equal to await. And I'm just going to call my repository dot insert user, pass in my user. And then down here, right after where it's giving me that throw because we haven't implemented it yet, add my logic here. And I'm just do return user. All right, excuse me, result. There we go. And we're going to just rinse and repeat for the other ones. Save time. I'm not going to do those for now. We'll come back and do those if we need them in just a few minutes. Okay, so now I've got my app logic built. I've got my repository built. Now I need to implement my service layer so that my application can pull stuff up. So in here, what we need to do now is I want to generate a service tier. Now, anybody that's built services before, it's a lot of typing because you have to make sure that you got everything set up correctly, use the right verbs for REST, and if you're using gRPC, plan for going back to the good old-fashioned WCF days of attributing the bejesus out of your entity objects. So what we're going to do is we're going to base our services off of our logic contract, not off of the repository, not off of anything else, but I want to be able to have my services run my logic, and that's it. That's all my service does. It runs whatever logic I tell it to. I can have any type of logic I want, and I can just project it to any type of service I want. So what we're going to do here is I'm just going to right click on my service, my logic, and say, hey, let's build a REST service. So you'll notice we built our REST service now. So the way this works is you're going to notice that when I go up to, or let's go down first, we're going to go down to our demo service REST. You'll notice that I now have a user management controller that's already built. And in here, what you're going to notice, I'll explain why this is here in a minute. That's a feature of the compiler. Okay, so you notice I already have my controller definition in here. I've got logger in here. I've already got my abstraction, my interface for my logic tier already built, and my constructor for my controller is already set up and running. So all that part's done. Here's my insert logic. Here's my update logic, and here's my delete logic. One of the things you'll noticing is I'm breaking some fundamental rules of REST by using posts instead of the actual verbs. This is by design. This is an automation level requirement. This is how we're able to solve some of the problems from an automation perspective. I have used Git. We still use HTTP GET, but I don't use delete. And all this does runs identical. And now all my functions come through. We transform to and from objects when I need to. In this case, because we're using REST, we really don't have much transformation to do. The one thing you'll notice that's a little bit different is that we have a custom object from the common delivery framework called the service result. And the reason why we return a service result is because of the way we use manage exceptions. So you notice so far, I haven't done anything with exception management anywhere in the system, and that's by design. A lot of exception management now is becoming automated. So if we go peek at the definition of this, let's see if it'll decompile it for us. There we go. So you'll notice with service result, all it's really giving us, it gives us our result data. Do I have any exceptions? If it does, it maintains a list of them as managed exceptions. Then what happens is on the other side of the pipe, I can tell it to rehydrate the exception directly from the message back into a normal exception. So for those of you that are used to using WCF, I'm now literally creating a fault contract. So we're literally just recreating faults, but using the rest to making it easy for app developers. This works fine with Xamarin. It works fine with any of the standard app frameworks. We also, and actually, it even works with JSON, as you have the actual message details already formatted from the exception. You already know what the exception type is. It's actually in native JSON format when you get it. So even if you don't have .NET and you're using a JavaScript framework, You still know what type of exception, you still have the full details of the exception already captured. So it keeps it nice and simple. So when saying, notice we have the insert, the update, and the delete. So one of the important things here is my developers don't write service code at all anymore, because we tie our services directly to logic classes. So what we do is there are times when we may compound or aggregate logic classes together inside of each other to build up more complicated objects. So for those of you that are used to the concept of microservices, same concept. We can compose more logic blocks on top of each other, build more and more complex services, just like this. The reason we move to a logic design is to handle service transformation over time. So for example, let's say that I want to not only have the REST version of this, but now our customers change their mind and now they want a gRPC version of this. Fine. So all we have to do is go back to our logic class up here and go to that interface. And now we're going to implement the gRPC version. So when I do this, it's done. All the code's built. You'll now notice that in our service tier down here, I now have a gRPC service. Now, the particular format of gRPC we're using the code first gRPC, not the implementation from Google. So this actually uses, and I'll show you what this looks like. I do know how to build the actual proto files from scratch, and we can do it this way using proto files. For what we're doing, our customer decided to stick with the code first approach. Once again, bounds checking, pass our calling context, our request object that we dynamically build on the fly. Here we automatically call our code, we get the exceptions, we manage them, we get a service result in the same way, and away it goes. And we transform to and from a gRPC model back to an app model when we're done on the other side. So what that looks like, when we go back over to our model RPC, you'll now notice that we now have some different objects. We have our user RPC object, and you'll notice that we have all these tags on this. These are proto contracts, which is using a third-party library that you can get download a NuGet that does the code first implementation. And what this does, it allows you to use attributes to drive the serialization so that I haven't used proto files. Notice it's all number sequence driven, which is the design for gRPC. And you notice I have the same extension method styles as before. I can create a gRPC version of the model, or I can create the app version of the model and transform back and forth. So all of our transformations natively built in directly into our entities as we build them. Now, once those are built, we then need some way to handle calling these services, and we also took care of that. That's what we have, what we call an abstraction layer. So in our abstraction layer, you'll notice that I have two versions of that user management abstraction. I have one for REST, and I have one for gRPC. The reason why you notice it, they're identical interfaces. We made a conscious decision to go ahead and name it by technology as a way to make sure that the consumer understands, and also for dependency injection, to make sure that we know it's going to the right provider. When you look at the abstraction, the actual implementation, they are very different. So here's the gRPC version of it. Once again, I get my service URL. This is that I talk to, my logger. I set up my security channel, build all that stuff up. I can then call my code. And what this does is this will call out to the channel. It'll create my model. It'll then call the channel and insert the model in. If any exceptions come on the way back, I go ahead and raise them right here. Let's do a normal throw exception per norm, so that my UI tier can now see the right type of managed exception and handle it. If it's not, it'll create back an app model and hand it back. Same thing for update. Now, obviously, delete doesn't have any data coming back as a delete option, but when we get that one back, we just get back the result, and the result is a no data, what they call a no data result. And all the no data result is checking if we have any exceptions or not. So we go back through and look at the same thing for the REST abstraction. It does basically the same thing. The only difference is here is that we're using the HTTP client to do our calls. We call on sure success code. This is the one that's built into the framework from Microsoft. We let it raise exceptions if anything happened directly on the pipe. Otherwise, we raise our app exceptions and let it go. So as you can see, we're using the actual definition of the data in source code as the genesis for how we build up and model and transform our code. So we just built a couple days worth of code in a few seconds. So the reason we do this is because technology keeps changing on us. So we isolate the things that we change by hand into these .NET standard libraries or technology specific implementations where automation really doesn't have a good fit yet. So for example, I don't really, even though I'm reducing the amount of code I'm writing, I'm still writing code in my SQL layer. So when I go out to my SQL repository, I'm still writing code. For example, I haven't built any of my select queries yet, but when I do, they'll get added in here. I'll still have these try catch blocks and my bounds checking. All of that will be built automatically. And all I'm really doing my work in is here and down here when I'm returning data. That's about it. So instead of, as developers, us focusing on things that really don't, it's everything, every line of code in here is important and it serves a very specific purpose and we need to do it. But a lot of developers cut corners because of time and money constraints. I can't tell you the number of applications I've seen without any type of logging whatsoever. In this application, every single stack level is automatically logged, every enter and every exit. Try catch blocks. Very few of my customers have full exception management built in. And that's a real problem. Okay. So that was the underwhelming code demo from the execution perspective. Is there any questions on this stuff so far before I actually show you how the automation actually ran? Okay. So let's take a look at how this thing actually works. So the first thing I'm going to do, I'm going to go ahead and save my project. And I'm going to close this out. Now, what I'm going to do is before I got a little too, let me reopen that back up. Actually, I just want the folder. So the first thing I'm about to do is I'm going to get rid of the automation. So to get rid of the automation, I'm going to remove that CFX file from the directory structure. I'm going to go down here. I'm going to get rid of this. And I'm going to get rid of the CodeFactory folder. Those are gone now. And I'm going to close this out. Now, I have another copy of this code already open. So what we're looking at is the actual source code that makes up that automation. And those are located in these libraries right here. 1, 2, 3, 4, 5. The actual automation that's executing is executed from this library right here, the automation delivery. The automation delivery allows us to be able to basically tell Visual Studio, hey, I want you to make things available to people and then execute a bunch of logic. These other libraries, Automation Common, Automation Data SQL, Automation Service gRPC, and Automation Service REST, are a series of extension libraries that give you the actual code functionality that does all the things that you saw underneath the hood. And I designed it this way on purpose because the goal of the Common Delivery Framework is to give you a truly running automation, but no automation, no matter how well it's built, is going to solve all your problems. A lot of times on a case-by-case basis, you're going to want to build your own or change what we've implemented or improve it or whatever else. And that's good. That's what we want you to do. We want you to get in there. We want you to be able to do these types of things so that you can build better code. And you can automate almost any situation, that as long as you can make it repetitive, you can pretty much do whatever you want. And that's the goal of what CodeFactory is all about. So what we're going to look at is I'm going to take a few minutes. I'm going to give us about 10 or 15 minutes going through the code because we've been drinking from the fire hose pretty hardcore. Then we'll stop and just answer some basic questions from there. So the delivery project is the one that actually gets registered with Visual Studio when it fires up. And what we have are a series of command objects, and we call these Explorer commands. So inside of Visual Studio, the Solution Explorer, when I right click on a node in here, these context menus pop up. Depending on which type of commands you tell it to load, it'll show up on that type of node inside of Solution Explorer. So if you notice, I've got really two types of nodes that we're tracking against. One is at the project level, and we'll fire this back up so you can see what I'm talking about. And the others are at code file levels. So I have one that runs at the project level and automatically registers all your transient classes for dependency injection. These other ones, this add members, this is the one that checks for any missing interface members and automatically writes that to the system. Here's the one for creating that SQL repository, the one for updating the gRPC service, the one for the REST service, and the one for updating that SQL model. If I have changes to the tables, I just want to update the model, great, update care of it. So the structure of automation is always designed to be as simple as possible. So let's go look at that numbers. So what you'll notice here is that we just had this command. This is going to go against the C# source code file. And you give it a title, you give it a description. So that loads, you will show up in the text menu. This description will give you more details about what the code's be for. From there, we have two methods that we override to implement. The first one is called enable command. What this allows you to do is this little check displays whatever automation you want to run. This is a chance for you to check the conditions to make sure that this should be run. So for example, if I don't have any interface members that aren't implemented, I don't want to display this command. I don't want you to even be able to touch it because there's nothing to automate. So I just hide it. I just don't show it. So to do that, in this case, I'm taking my data model that's been sent back to me and I'm checking. I got this little extension method that says, hey, I want you to give me a list of missing interface members. If there isn't any, if there is some, great, it's enabled. I want to display it. If there's not, okay. And this is where I get my specific things. In this case, I want to make sure it does have logging. So if it does have missing members, great. I check to make sure if the project data, so I go get my hosting project, literally just call this command, gives the project this code files in, says, okay, hey, you have these reference libraries. Do you have the Microsoft.extensions logging abstractions? If you do, great, let's turn it on. If not, let's turn it off so it doesn't display. Once you have it set to enable, you return that back, it'll display it in the context menu in Visual Studio. Once you click the button, this second command will then fire. And this is where the logic actually runs that gets your information. So the first thing I do is say, okay, go to that source file and go ahead and give me the missing interface members for this. It gives me this return list of missing interface members. If there is none, I'm ahead and exit out because we didn't have. I'm going to tell it to output logging. I'm going to tell it to also output bounds checking logic. And if it does, and I want this to support async, which means if it has a return type of a task type, it'll automatically build it as an async aware method. And then literally all I'm doing in this example is I'm going through each missing member and I'm telling it to add the members to the class. And I'm literally telling it, yep, do bounds checking, enable logging, and support async. And then as I keep digging lower and lower into this, which we're going to look a little bit more into it, once I look at this one, let me go to the definition on this one. You're going to see now that we're in automation common for common delivery framework. And this adds missing members to a target class. So I pass in my source code where my class came from. I pass in the target class I want to update. I get my list of members that are missing. And then I have some options. Do I want to implement bounds check logic with my members? Yes or no? In this case, the default is true. I can set it to false if I want to. Do I want logging logic? It's optional. Yes or no? And do I want to support asynchronous methods? Once again, it's optional. From here, I do some bounds checking of my own to make sure that nothing's missing. If anything is missing, I'm going to throw it back. If any of my data are not loaded correctly, I'm going to throw it back. And then from there, I'm going to go ahead and start checking to make sure everything is there. So the first thing I'm going to do is if I do have logging logic, I have a current little helper that says add Microsoft extension logging field. So I'm just going to peek this one. And all this does is it gives me my class, gives me the name of my logger I want to implement, and the source code that this class is a part of. It checks to make sure, do I have a logger in there? If I don't, I make sure I add the namespace. So I'm going to add the namespace, Microsoft Extension Logging. And then what I'm going to do is I'm going to create my property, or excuse me, my private field that'll store the logging. So if you see here, I have something called a source formatter. And all this is literally just that. I'm starting to write source code. So all I do is I append this. This is nothing more than an extended string builder. I pass in my logic. There's my I'm putting my summary tags in. This is private read only. I'm passing in my constant and my name of my logger. And then I literally go to my class object and say, hey, at the beginning of the class definition, write out this block of code directly into it. As soon as that literally writes it inside Visual Studio directly into that source code file. And then we return. From there, I can go through each one of my missing members and I can check if it's an event, I want to format an event member. If it's a method, I want to format a method member. If it's a property, I want to format a property. We'll briefly go look at member method. So once again, I'm going to peek that definition. And in here, once again, I'm making sure I got my data. I'm creating a source formatter that I'm going to write all my method data to. Okay, does it support asynchronous syntax? In this case, I'm going to go ahead and call an extension method that actually builds up a method signature. It literally just builds the method signature with async or without. Once I got my method signature, I get my documentation. I start writing my documentation directly to my formatter. If it has attributes, starts writing my attributes. And then I start adding my method definition. If I include logging, add the logger. If it has parameters, check for bounds checking. If it's a string type, write out my string type bounds checking. If it's a value type, ignore it and keep going. Here's my try block. Here's my manage exception catch block. Here's my unhandled exception block. Here's my exit or editing, my to-do logic, all of that. So the point is, the goal of CodeFactory is to give you total control over how you emit code back out. And I can use data directly from my existing source code to write it out. Now, when we run this, one of the things I can do is we can debug Visual Studio directly from CodeFactory. So let's say for a minute, I wanted to see how this source code works. So we're going to go add members to class. I'm going to put a breakpoint right here. I'm then going to go ahead and fire this up. Okay. So now we got our another copy of Visual Studio up and running, and I'm going to go ahead and open up our automation testing project that we were using earlier. Now, one thing I'll forewarn you about, debugging Visual Studio takes time because we're actually loading a full copy of Visual Studio and all the debugger symbols for the entire platform. So you'll notice in the lower left-hand corner here, this is going to take it a few seconds to get everything up and running. And when you're presenting, it even goes slower. For whatever reason, the message pump with WPF doesn't like dealing with user presentations. We'll give it a second to catch up. And once it catches up, we're going to update our user logic, and we're going to add another def method to the interface definition. Then we can then debug into it so you can see how that works. Any questions while we're waiting? I've got an easy crowd tonight.
Yeah, I was going to say, normally at this point, people start snapping circuits when we talk about this. So I laugh. This is John, by the way. We laugh. This is kind of inception. This is, writing code that reads code to write code to build code. It's about four levels deep. Takeaway is that you're writing C# code here that uses another application code base as its data model at the 50,000 foot level, right?
Exactly.
Steve, this is Bill. So another maybe point to share with the group while it's doing its thing in the background is just reminding everyone that a lot of our open source solutions are sitting out on GitHub. CodeFactory is downloadable from codefactory.software, and free trial licenses and all that. I know you kind of alluded to that earlier, but
I have a question.
Yeah.
Why is Dapper in your using list there?
This was a design decision. Let's talk about that for a moment. So I'm not a big, I really don't care what you use as long as it's useful. So one of the things that we're using that's becoming really popular with a lot of our clients is we follow the 95-5% rule. And so for about 95% of our code, we use Entity Framework abusively. Okay, there are commands loaded. But for 5% of the code, we run into really, really complex joins, which Dapper excels at, and Entity Framework just frankly sucks at. So we intentionally load both side by side, and we only use Dapper for the scenarios where Entity Framework doesn't do well, which is very few.
Very nice. I figured that's what it was. I just wanted to make sure. I'm a big Dapper fan, so yeah. Between running Entity Framework Core 6 and Dapper, yeah, this awesome database stuff.
Yeah, it's great. And if you notice, we very intentionally stuck with Entity Framework for a good chunk of our work. And but when we get into really weird situations, like for example, like statements, the built-in functionality for like statements, believe it or not, inside of Entity Framework, it's gotten better, but it still can't compete against Dapper. It's bizarre.
You have examples that show how to use that hybrid?
Not tonight, unfortunately. Yeah, not tonight, but I'll definitely provide some examples later on when we get this thing a little bit more fleshed out.
Perfect, because I'll be the
Yeah.
first one to say this is a toy I want to play with.
There you go, man. So one of the things you'll notice is when CodeFactory finishes loading, it'll tell you, hey, here's my commands. But if you're ever wondering, you go up to extensions CodeFactory, you can always get a list of all the commands that are loaded, so you know what you got up and running right now. And by the way, I'm using the UI here was built using CodeFactory. This wasn't something I custom built inside of my extensions to Visual Studio. I just use the CodeFactory libraries that we use for building screens, and I put this up there.
So
it
this
could be a lot.
The ultimate dog fooding.
Exactly. That was the whole goal behind it. So now when I go into, so let's go back to our definition for our logic layer, and let's go ahead and let's extend it now. So maybe we need to get some data. So we're going to break the cardinal rule, and we're just going to say, let's get everything. So I'm going to do a task, and we're going to get a list of user. And I'm just going to say, get users. That's it. A team. And I'm going to go ahead and put some documentation on this. Gets all users in the system.
I noticed it was even going to make a suggestion for you there.
Go ahead, Ben, please.
No, your code was going to give me a method name suggestion already.
Well, that is, believe it or not, that is the AI tools from Visual Studio.
Nice.
So if you have AI turned off, turn it on. It's really kick butt. Now, obviously, in a production system, I'd never recommend getting all of any table, unless you know that table is going to be very constrained. But we don't care about that for this particular example. So now I've got that additional method defined in my interface. Notice I haven't saved the code yet. And there's a reason I'm bringing this up. So what happens is, notice that add members still came up. So one of the things that we do with CodeFactory is we run the compiler real time. So the second you hit the right click, it did a real-time compile on that source code, even though it's not saved yet. So we always guarantee you'll have the latest version that's in the IDE on the fly. So now we go to do add members. You notice we went directly to our breakpoint. So now we can actually walk our code and watch all this stuff run. Now, I'm not going to spend much time on this because we really don't want to take that much time. But just like with anything else in Visual Studio, you can, you can check to see, I can add missing namespaces if there is any. I'm not going to actually walk through that code. But it's very easy for someone to, if they don't understand how a certain type of code works, we definitely want you to get some time to be able to play with this. So let's go actually watch the member format run.
Well, let's be honest, don't like the way we formatted it.
Oh, exactly. The one thing that's very important here, and the reason why we actually built CodeFactory the way we did, is everyone's got a coding style. And I don't want to reinvent someone else's coding style. If you don't like the way we did it, great, build your own. Here's the full source code that we built. If you don't like the way something works, please change it. And if you're really nice, you may give us a copy of it so we can extend ours. You
have instructions on how to do exactly that?
On what's that?
Do custom code formats, because if not, you should.
As far as, we have full documentation on the SDK.
Cool.
So yeah, so it's fully documented out there. But we wanted to give full running examples like this on purpose to make it easier for developers. So if you have an existing problem being solved, it's a lot easier to go look at someone else's code that's already done it and then say, oh, I understand what they're doing here. For example, here I'm just copying literally the lines and outputting it to my formatter. I'm literally just looping through. This is just an enumerator. It's just enumerating the actual documentation. Does it have attributes? Nope. Does it include logging? Well, yes, it does. Okay, now let's put our logging code block in. Does it have parameters? Nope. Skip all that stuff. Here's our catch block. Here's all of our details. Here's our exit statement. And there's the parts and pieces we return back from. And I'm telling it, hey, add this to the end of the code file. There it goes. And there we are, we're done. That's the last of our missing members. Oh, we're not going to get into nlog. And now our code's complete. So now we go back to our other copy of Visual Studio that's running, and you'll notice now we go into my here's my get users code, and it's ready to be implemented now. And now that I have my get user code, I can now say, okay, let's say this was, I'm not going to update this, but now I need to update my services. So I go back up to your user management. I'm going to go ahead and update my REST service. Okay, my REST service is updated. So now I go down and look at my REST code. Delete, update. There's my get users. So one of the other important things is I can regenerate this stuff real time anytime I want without impacting the system. So it's designed out of the box to be very easy to update and maintain.
Hey, Steve, I think I want to make a point about that actually, because I noticed in other code generation tools that are out there, that's a really important thing to note for those who either have done automation in the past or have not, is that a lot of other code generation tools is kind of like a one-time automation, like a one-time thing. CodeFactory is actually smart enough to know what properties are in the namespace manager and methods and method body, and kind of dissect that so you can chunk out whatever you need and then recompile everything back together and throw it back into a class. That is really important when you're making when you're refactoring code. So is huge.
One other thing I wanted to bring up, because I didn't show it earlier, is inside of the common delivery framework, we have the concept of using what's known as a leaf to trunk dependency injection pattern. And what that means is, excuse me, unlike a lot of implementations where I go into the startup inside of my service and I have to register all of my transient classes by hand, that's way too much work. So one of the things you'll notice here is I have this loader class in each of my libraries. Now, if you'll notice in my SQL data, every time I added a repository, it refreshes on the fly and automatically re-added all my services. So all of my repositories got dynamically added. So now with my logic, it doesn't do that. So if I go to my logic layer, I've got this one in here, and that one's incorrect. So I'm going to go ahead and I'm going to update this. So I'm going to say, okay, let's register my transient services. Now it's correct again. We're good. So notice I did that on that command came from the project node, not from a code node. So I have total control over when certain logic's available and when it's not. I can't go down to user management and run that. And notice now, when I go down to user management and I run it, I don't see that add members anymore because all the members have been implemented. And that's by design, the way it's laid out. Okay, so the goal of what we've been going with tonight has been to focus on how can I abstract away work that's repetitive in nature. Building service implementations is very repetitive work. Building entity objects is very repetitive work. Building try-catch blocks, building logging, error handling. All of these things are just extensive amounts of work that slow us way down. So to give you an example, a real world situation, I'm working for a customer here in Phoenix right now. We're porting an existing system to a new platform, and we're moving from ASP.NET MVC to on the .NET framework, and we're using SQL. We're using the old SQL entity tool that Microsoft had back in the day, and we're moving to Blazor server-side Blazor, and we're using REST services now. So the decision was made that we're going to rewrite the UI, and we're going to reuse the existing database, but that's it. Everything else is up to us. So now I have 2 additional layers in that design than what you see here. And I won't go what they are, what they're for, but one of them is the Blazor project, which contains our UI and our controller logic. But literally, my developers write code at the Blazor level where we're building the UI. They implement the logic layer, meaning they fill in the blanks in the logic, and they build the repository. That's it. Everything else is auto-wired from the ground up. So my team is averaging a screen every 2 days from start to finish. And what I mean by a screen, I'm talking about a screen with 20 to 30 fields at a time with full logic at the back end in the repository.
And just for the sake of those of you who are newbies, to have a screen come out every 48 hours is about 10 steps beyond massively impressive. Normally it takes over a week per screen. This is awesome.
Yeah, so the only difference between the code that I've demonstrated to you tonight and the code I'm using for my customer is they wanted to have multiple layers of modules. So I put module detection logic in the automation. So it can detect, hey, this is this module, this is that module, and it detects it for the service layer. So we have modules for each service layer. We have modules for each repository layer on purpose. So I just put detection logic on top of what you see here. So from a usage perspective, if you guys want to get your hands on this, if you go out to GitHub, if you go out and you type in Common Delivery Framework, you can find this. Now, this code base right now is still in beta. I want to get that project cleaned up so that you guys have a sample project. But if you want to get at the source code, go pull your copy down. Just go to Automation Beta for the branch, and you're up and running. If you go back to CodeFactory LLC, this is the actual CodeFactory itself. It's where you can download it right here. Here's the runtime for Visual Studio 22. If you go back and look at a release back, you'll see the runtime for 2019. They're both fully. And you'll install a physics package, and that physics package natively plugs it into Visual Studio. And we are not charging for the runtime license. So if you just click on the CodeFactory license, you can get your license key. And they're good for each key's always they're good for at least a year. We have full documentation. So if you go out to docs.codefactory.software, here's all your guidance. Here's your SDK documentation. You can get in there and have fun, look at the different things that CodeFactory can do. And then we very intentionally set up CDF, the Common Delivery Framework, as a very easy way for people to work on things. If you want to see some other interesting projects, John Hanna built the Web Forms to Blazor server project. This will take an actual web forms application and literally lift and shift into a Blazor design all the screens and lay out all the code and actually move it. It won't run because it's old code, but it'll give you a place to literally pick your architecture up and drop it into a new architecture. It's some pretty cool stuff. So is there any questions I can answer for anybody? Because that's pretty much the end of our demo.